Welcome back to another rigid body problem, equilibrium of a rigid body. A semicircular rod ABCD is maintained in equilibrium by the small wheel at D and the rollers at B and C. Knowing that alpha is 45 degrees, determine the reactions at B, C, and D. Alright, this is equilibrium of a rigid body. Step 1 is always draw a free body diagram of your rigid body, which in this case is kind of obvious, but it's that semicircular rod A, B, C, D. And step 2 is use your equations of equilibrium, the three equations that I have in 2D cases. Summation of forces in X should be 0, summation of all forces in Y should be 0, and summation of moment about any point you would like, it should be 0. Alright, let's just start with step 1, drawing free body diagram of this. So free body diagram of my semicircular rod. Sorry, the microphone just fell. Free body diagram of semicircular rod ABCD. So step 1 is isolate this rod ABC and draw the outline of ABCD. So I'm going to do my best to draw a semicircle here. Not bad. Step 2 is to put active forces or moments on there. When I look at this, the only active force I see is that P. I can just draw it as is, but I have the angle. Let me just draw it like this. P cosine 45. P sine 45. And next, put reactive forces and moment on there. These are results of constraints and supports, and the forces being applied to the body, they each develop a reaction. These are all rollers or smooth surface. Please watch previous videos that I've explained how to find reaction forces with support such as roller or pins or stuff like that. Somebody might think, well, there's a pin here. Yes, but all I care about is the support and how it's supporting my rigid body, which is a smooth surface. So in each case, I have a normal force perpendicular to the direction of this roller. So I will have a force right here of N sub B. They go through point O. I have another one of C, and I have one at point D, which is straight perpendicular down, and I call it ND. I think this is all I need, and I'm done with my free body diagram. Next step is to apply three equations of equilibrium and find my unknown. I have three unknowns. P is one of them, NB and NC. It looks like I have two forces, P sine 45 and P cosine, but only the P is unknown here. And I do. So I have another one. I have 4. So what I can do is I can find each of these reactions in terms of P. So find each reaction in terms of P, because P is an active force. Then if P is 150, whatever it is, I can just find it. The unit doesn't even matter. It's in newtons versus pounds. I should be able to find it. All right, let's just start with our three equations and start solving. So I kind of redraw it here. Starting with equations of equilibrium. Both NB and NC, they pass through point O. So let's take a moment about point O in order to find my ND right away. So summation of forces, summation of moments about point O should be 0. P cosine 45 that passes through point O, I don't have to worry about it. P sine 45, however, has an arm of R until point O. Trying to rotate this way, it is with my sign, so that's positive. NB and NC, they go through point O. Next, I have N sub D. Moment arm is R. It's trying to rotate this way against my sign. That is negative. So my equation 1, again, remember, my goal was to find everything in terms of P. So in this equation, which should result in ND equals P sine 45 degrees. All right. I'm going to name this one equation 1. Then I can move on to my summation of forces in x equals 0. All right, I always like to start from one side and kind of make my way through. The first thing I see is P cosine 45 degrees. P sine 45 is vertical. Next, I see NB, and that should be cosine 45. That is a plus. Then kind of moving on, I see an NC, cosine 45, and that is a negative. And then that's it. ND is vertical. All right, I could just get rid of cosine 45 in all of that. This should result in P plus NB minus NC equals 0. Okay, that's a nice equation, but there are two unknowns in it. Let's name this equation 2. And let's write our last equation, summation of forces in y. I'm going to go a little bit faster here. Minus P sine 45 plus NB sine 45 plus NC sine 45 and minus ND equals 0. I have my ND right there, so I can just write this as P sine 45 degrees. All right, sine 45 and cosine 45. I could just get rid of all of these here. This results in minus 2p, because I have 1p here, 1p right there, minus 2p plus NB minus, plus NC equals 0. All right. Let's call this 3. All right, let's see what we can do. Between 2 and 3, if I add those two together, add those two equations together, I get the NB, sorry, this is a plus. NB, P, okay, I should have minus or negative P, NC get canceled, plus 2NB equals 0. All right, this one is good because it gives me NB equals half of P. All right, let's see. If I subtract these two equations, then I get P, so I get 3P in this case, and then in this case NB get canceled, plus 2NC equals 0. All right, this is also nice. It gives me NC equals 3P over 2. So 1.5 times P. I can put and ND, I've already found it right here. ND, P sine 45. If I want to do that, I can just say ND equals P over square root of 2. So these are my three forces. So if P is known, 20 pounds or 20 newtons or 100 pounds or 100 newtons, I can find the other 3 reactions in this problem. Thank you very much.